Welcome back to my channel Active Catalyst. In this video, let us understand the important questions of Module 3. Before I start, I'm not getting complete support from your side. So I am expecting at least 20 comments, whether it helped or not. I'm not expecting any thankfulness or anything. I just want whether it is helping you or not, because that will motivate me to make more and more videos and help each other to grow. So let us begin with this video. So I think I'll make it like this. If I get at least 25 comments, then I'll upload this notes, because many of you are downloading the notes, uploading it in reels and all, but not giving the credits also. That is hurtful to me. So let us begin with this video, hoping you will follow what I've told. Thank you for that. So let's start. So first question is, explain cursor and properties in embedded SQL. So simple. Cursor is a control structure that enables traversal over records in database. So remember, C cursor, and it controls structure. It is a control structure that enables us to retrieve the data from one particular database. Simple, right? Okay. Then properties. How to remember properties is here do FCD. Okay. Then D stands for declare. Why do we need to declare? If we need to define the cursor, we will use the word declare. Okay. DD. Then open. Why do we need open? If we want to execute the query which we have used cursor, then we need to use the word open. Then fetch. Fetch is to retrieve individual rows. Remember, it is for individual rows. Then close. Close is to release resource associated with cursor. Resource means particular data or information. Okay. Then delocate. It is to remove or delete. That is also fine. Okay. And one example we have taken. See, write all these words in same order. Now I'll explain this part. Okay, so declare. We have to declare the cursor, right? So we will write the cursor name provided by cursor keyword. For select, we have to select something, right? So remember, only one thing is extra. When you write this order, select is extra, because we have to select something. Only then it gets displayed, alva. So select name from any one particular cursor. Here we have declared it as employee cursor, so use same employee cursor. Open. First we have to open it, right? Because this part should get executed. So open employee cursor. Fetch. Now you assume that there is some details. You want to add some extra details. In that case, fetch next from employee cursor into. You can add any values, that is at name. Then close it. After you close, after everything is performed, you can delocate it. Just like how we drop the table in SQL queries, here it is delocated. Then next one is, what is normalization, and explain 1NF, 2NF and 3NF. Before that, here it is given for 6 marks, right? So you have to explain cursor. For that definition, they'll give 1 mark. For properties, they'll give 4 marks, and this part that carries 1 or 2 marks. They can give hardly 1 mark. Okay, like as per I've gone through scheme of evaluation for module 3, we are very strict, like allocating very less marks for lengthy answers. So in this module, you are expected to write more and more examples. Okay, more than theory part, they are giving marks for examples only. So what is normalization? It is very simple. See, process of analyzing relational schema. Okay, relational schema based on functional dependency and primary key. Okay, simple one. Then why do we need this? We need this because it minimizes redundancy. Redundancy means repeated values. That can be reduced by normalization. And insertion, deletion, updation, anomalies. Anomalies is like something problem is occurring there that can be solved. Okay, that is anomalies. Now let us understand what is one normal form. Okay, it is very simple. A relation is in 1NF if it accepts only one value. It should accept how many value? One value, and all attribute values are atomic. Atomic means it should contain only one values and it cannot be divided further. I hope you know what is atomic values, like integer, float and all are atomic values, right? Same thing. Now let us consider one example, like you can see D name, D number and D location column. So I will say this is not in 1NF. Can you think why? It can be, yes, you're right, because B and G, Bangalore is here, Mysore is here, Mangalore is here. According to our rules, see, it has told it should accept how many value? One value. But here it has accepted 3 values. Now you want to convert this to 1NF. Then how can you convert? So there are 3 main ways to convert it to 1NF. So first one is we have to expand the key. Like how it is see, write it separately, like CS1 Bengaluru, then again CS1 Mysuru, again CS1 Mangaluru. That is this one. But it causes redundancy, that is repetition of values, right? So there is again problem. One more way is there, that specify number of columns. So we can specify, instead of, see, according to the rule it should accept only one value. But what if we make this as 3 columns? Yes, we can, right? So if you split all these 3 into 3 columns, then again, like for second one, there is only B and G, right? So null values will be added. So this will add null values, okay? Okay, next we will understand what is 2NF. So remember, if you write this one line, they'll give you 1 marks. It should be in 1NF. Then see, 2NF, second NF is based on functional dependency. See, understand this very simple. No non-prime attribute are functionally dependent on subset of candidate key. Now don't get confused, it's easy. Non-prime attribute means we will have one key, right? Okay, let us think of this one only. Now let us think that D number is the key here. Remaining CS and this part will be non-prime attribute. This is prime because it is primary key. Like that you can remember. Okay, and candidate key, I hope you know what are candidate key. So we'll consider one example. You will understand it better. Like if you have not understood this part also, through example now you will understand it very clearly. I am sure. Watch it now. Okay. So we have 3 different tables here. Okay. Now see the steps to convert or steps to get to 2NF, that is written here. Simple one. If you go through any other videos, the lengthy ones, lengthy examples are there. So far what is there, but I'll try to explain it in a very simple way. First step is we have to identify the key in all of these 3. To identify key, we have to apply closure property. Don't get scared, again I'll explain. Okay, first let us consider the first one, that is EMP department. Okay, in EMP department we have EID, right? So we'll take EID. Plus means closure property. So first actually you can understand, right? EID here is the primary key because it is uniquely used to identify all other attributes. So EID, see, remember in closure property or writing the closure time, whatever is there in the left side, that should be written first in the right side. So EID as it is, then E name as it is, ED number as it is, D name as it is. Now you check whether by using EID anything else is derived. Yes, look in the second one. From EID even E name and ED number can be derived, right? Yes. So like the one key attribute, by using that we can derive so many things, right? And from by using ED number, see here, ED number is used to derive D name. So all are related to what? EID. Just if you have EID, you can derive all of this. So that is why it becomes the key. That is primary key. After you find out that, you just write the entire relation, like whatever attributes is there, right? You write it. Later represent it like this. Like by using EID, we can find out E name and ed number. Even d name can be found out, but it is written separately here because they have given a different relation, right? So now you have to identify non-prime attribute. Non-prime attribute means, just refer here, see, kindly look here carefully, wherever arrow is pointing, right, that is non-prime attribute. Okay. Then we have the 3NF concept. So it must be in 2NF. Okay, first condition. For this you will get 1 marks. Then all non-prime attributes are directly dependent on entire candidate key. Means, don't worry, when you get final answer, x should be the key and y should be the non-prime attribute. That's it. Okay, and same example you can explain. Next, third question, informal guidelines for relational schema. It was asked for 4 marks and 4 points are enough. So trick to remember is S, R and S. Okay, the first one is semantics of the relation, which means that naming must be clear. Next one is redundancy information in tuples and updation anomalies. So regarding this, what you have to explain, you will understand when I explain next topics. Okay. Then third one is null values in tuples and spurious tuples. Spurious means unwanted tuples, like some values in the database may be unwanted, right? So that details. Next one is, what is functional dependency? Write the algorithm to find minimal cover for the set. See, functional dependency is nothing but, assume that there are two attributes, like two attributes in two tables, x and y. Then attribute present in x must be present in y. That is how they have written, like t1 of x in table 1, if there is x, then that x should be present in table 2 also. Similarly, if y is present in table 1, then y should be present in table 2 also. Now let us understand the example. So this is a little bit complicated. I have explained one more example that is easy for you. Okay, so we'll check that. So this is the given question. In step 1, what we will do is, if in the right hand side we have two characters or two letters, means we will split it up, like A belongs to B, A belongs to C. Okay, we have split it up. Now you may ask, left side it is A, B belongs to C, right? Can we write A belongs to C and B belongs to C? No. In these rules only right hand can be split up. Okay, so we will split it up. So when you split it up, 2 times you can find A belongs to B. Okay, so one is duplicate element, you can ignore that. Then in step 2, we have to check if functional dependency can be applied. Now, functional dependency means same thing, like we have to find the closure of each one. Like first we will take the first one, A belongs to B, C is there, right? So first for A, I have told, right, if you are finding the functional dependency, first write the first letter as it is, right? So write it as it is. Okay, then B, C. Why B, C? Because B and C is here. Then see, this can be written, right? We have already written it also. A belongs to B, A belongs to C. Then similarly find it for B plus, that is B closure. So B, you can see here, B is belonging to C also. Is B belonging to anything else? Yes, B is belonging to C also, but not A. Hence we cannot consider this part. Okay, then what we have to do? Remove redundant value. Means, now see here only we have told, right, A belongs to C. Once more, do we need to specify that A belongs to C? No, right? So remove that A belongs to C. Now write whatever is remaining. A belongs to B and B belongs to C. That is enough. Next we have explain type of update anomalies. Remember, we have 3 types. In the last module also we have update operation, right? Here we have update anomalies. Anomalies means what are the problems that will occur. We have 3 kinds: insert, delete and modify. Okay, now understand this carefully, because this is example is the simplest one where you can understand clearly for the first time. no need of going for other videos. Okay, so we have to consider, see, while explaining anomalies, we have to consider two tables. Okay, so this is design 1 and this is design 2. Two different tables. Okay, fine. Now, see, look in the table 1. Okay, like this is dependent on this. So here in first table, I want to insert 114 Chetan. That is this part I want to insert. So how do I insert that? Here if I want to insert C114 and Chetan, here it becomes null, right? But in the second table if you want to insert, see, if I am inserting here, I am getting only one null value, right? But in the second table if I want to insert, I'll get how many null values? 2. That is what you have to write. This is the like drawback of it. Now let us consider one more example. Like it is difficult to insert new department value without employee details. Means what? Like if you want to like add up only the department details but no employee details, then you can add here. Will it reflect here? Here it will be null, right? Similarly, if you want to add only EID and ENAME but not this one, it will be affected, right? So this details will be lost. In case of deletion, I'll explain it again. If you have not understood, don't worry. So consider design 1 and design 2. Here what we are doing is we want to delete only this part. If we want to delete only this part, is it possible when it is two different things here? Yes, you can delete it. But if these two things are together, and if you want to delete only D number and D name, is it possible? No, right? Even if you try to delete, these details will be lost. So that is the drawback. Then modification. So in modification, what I want to do is consider again two designs. See, this entire question is allocated for 10 marks. That means for each anomaly, you have to write two tables and then explain. So in modify, what I want to do is, so there are two tables, right? In place of CS, I want to write it as CSE. But I want to reflect it only for Govind, CSE. If I try to change D name as CSC, everywhere it will become CSC only. No, but I want only to make one D name as CS. Is it possible? No. We have to go for complex queries, yes, but in simple this thing, it is not possible. That is what we have to explain. Then we have explain alter and drop command. So why do we use alter? First of all, it comes under DDL, data definition language. If we want to modify the structure, then we use alter commands. In alter, we have add, drop and modify. So add, when do we use add? When we want to add new columns, right? So alter table employee add commission. That will be the this thing to add new columns. When do we use drop? We can use drop either to drop entire table or to drop column. Okay. Then when we want to modify, like if we want to modify data type, alter table employee modify commission. Commission before it was varchar. Now we are modifying it to int. Then what is the purpose of drop? Drop is used to permanently remove. Okay, like dropping the table or dropping the entire database. Then we have informal guidelines rules. Simple. Reflexive. We had this relations, right, in second PU, if you remember. Reflexive, transitive, symmetric, same thing. Here symmetric is not there, that's it. Reflexive, augmentation, transitive, decomposition and union. 5 rules are there. It will be asked for 10 marks. By writing condition you get 1 marks. By writing example you will get 1 marks. Reflexive is simple. If A belongs to B, then B is also the subset of A. Okay, that is what I have written. Then augmentation is simple. Like if X belongs to Y and you are adding something on both the sides, then both will be equal. transitive. Okay, let us assume that x is belonging to y and y is belonging to z. Now look what is common. This y and this y is common, right? So remove this both, remaining whatever is there. X is remaining, z is remaining. Write it as it is. Then we have decomposition rules. Simple. If x is split into y and z, it can be written as x belongs to y and x belongs to z. I told it, right, while explaining the functional dependency. Right hand side can be split out. Same why we can split out is it is according to decomposition rule. Then we have union. Union again. See, here we are splitting, here we are uniting. So x belongs to y and x belongs to z. Then x belongs to y and z. Okay, actually one question is they have given two like functional dependencies. We have to check whether they are equivalent or not. So like how you can check equivalent or not is very simple. Write all the given things in this form. What is this form? I'll tell you. First let us write for f. Okay, we'll consider f. A belongs to C, write it as it is. Now A belongs to like AC belongs to D is there, right? I like you split it and write, but you cannot split when it is in the left hand side. So just wait for that. Like you just write as it is, like AC belongs to D. Then E belongs to A, E belongs to D. Similarly, E belongs to H. Write everything as it is. Now come to second equation or second functional dependency where it says A belongs to C, also A belongs to D. Write it as it is. Then E belongs to A, E belongs to A, then E belongs to H as it is. Now how to check whether they are equivalent is very simple. By taking each one of this, we have to find the closure. What is closure? Like if you are finding the closure for A in first relation, first we will write that letter as it is. Is A giving us any other variables here? Only A. It is AC. We cannot consider it, right? So A is giving C. Yes. So AC. Next one we will consider. What is AC giving us? AC is giving us D. Along with D, it is also giving A and C. Like split it up and write, okay? Similarly, next we will consider what is E giving us. E is giving A, E is giving D. Also E is giving us H. That is what I have written. Okay, now come to this hand side. Is A giving us CD in first relation? A is giving us CD? Yes. Then is A giving us AH in first relation? Yes. So hence these both are equal. See, if you have not understood this, it means that this thing you have not understood clearly. Just re-watch this, okay, these rules. Take time, like pause the video, look in the content, you will understand. So maybe like if you are little bit like you have forgotten about the reflexive thing and all from second PU, then that might happen. Then we have data types in SQL and we have to explain substrings in SQL. That is the question asked in PYQ paper. Now first let us look into the data types. So number you already know, it will take integer values. In number we can mention m, where m means total number of digits that we can mention and n means number of digits that we can mention after decimal point. Now see here, I have given the age number. Obviously age will not be in the decimal, we both know, but it's just an example, okay? So 5, I'll write it as 5. Okay, 5. That means here only 5 values should be there. 1, 2, 3, 4, 5. But 6, 7 is also there. So it is not according to our rules. Similarly, comma 2. 2 means what? N means what? Number of digits after decimal point. I have given 2 but I have written 4. So it is wrong. Then character. Character is specified within single quotes. So active catalysts. Okay. We have character and varchar, right? So character, it is written as static and varchar it is written as, it is used when it is dynamic. If we want to allocate the memory dynamically, then we will use varchar. Then we have bit and bit varying. When do we use bit is when computation value is bulky. Okay, and you can just represent the bit in the form of array. Then we have date and time. So we have to mention it in this form, hour, minutes and seconds. Then timestamp. In timestamp we can mention time along with the date. First write date, month, year followed by time. Okay. Then timestamp with time zone. Time zone is nothing but AM and PM. That's it. Okay. Then one more question was substrings. See, substring is nothing but if we want to find the substring, we will use like operator, which is case sensitive. Okay. What we will compare in like by using like is character of the string. So syntax is first we will write the column name, like and pattern. If in simple, if I have to say, we have studied recently ADA, right? In that we had something called as horse pool algorithm. Like give one particular text will be given, we will find one particular pattern. Same thing in SQL, we use the operator called as like operator to find the substring. Now we have two kinds of like operators. Percentage matches with 0 or any number of character. Means, now see here, I will write around. Now if you write like in the SQL query A, and if you put percentage in front of it, whatever may be the character after A, it will give around, entire detail will be printed. But if you want to certainly find exact character or single character, we will use only one dashed. Okay, so like if you want one particular pattern, which like if there might be a question where find all the names of the students who starts like name starts with A. I hope you know. Okay, then we can use this. But second condition you can use when find all the name of the students whose name has only 2 letters. Just an example, don't take it seriously. Okay, and belongs starting from A, like that something. Okay, now I have told that like operator can be used for characters. Can it be used for numerical values? Yes. For all arithmetic operators like plus, minus, asterisk and percentage. Then there was one question they have given and they have asked us to convert it to 2NF. How do you convert? So to convert into 2NF, first we have to check whether it is in 1NF. How to check whether it is in 1NF is like look at the question. There are only 1 values associated, right? So hence it is in 1NF. Now how do we make it as 2NF? NNF is like we have to find out the candidate key. Okay, we have to find what? Like candidate key. How to find candidate key? See here, SSN, like SSN is taken from second relation and P number. Okay, P number is here. I've written it here in shortcut. Sorry for that. P number is somewhere derived from this thing, right? This one. So these two things are taken from other two things, like other like what I have to say is attributes, right? And that is why, see, this is like A1, A2 and A3. From A2 and A3, the primary keys of A2 and A3 are taken and written in A1. So if two primary keys are combined together, it is candidate key. So if that is the case in given question, it is 2NF. Similarly, if they ask you to do 3NF also, you should be able to do. What is 3NF? I'll explain it again. Then one more question was what was asked was explain all DDL and DML statements. So you have to write syntax and give an example. So create, can you tell why do we use create? To create the table. Then drop, to drop any particular column or to drop one entire table. Alter, in alter you already know, we can insert, delete, modify, do everything, right? You already learned it. Then again insert values, delete particular row, column and update. In update what all will come? You already know that, right? Okay, then one more question was given. and first question what they have asked is list all students studying in 4th sem C section. Okay, I hope you know the syntax is select from where. Now our problem what happens is list all students studying in 4th sem they have given. Sem is present here. Okay, sem is present here and section is present here. But they have asked us to list all students, means name, right? Obviously it is name, but it is present here. That means we have to join student and sem section. Okay, so that is why we are joining student and sem section. Also we have to join like class and student USN. Okay, so class and student USN should also be joined. Just go with the syntax, it is simple. Like if you want to combine, what we want to combine from two tables, like this is class table and this is student table, we have to combine USN. Then second question what they have asked is compute total male students. So we have to add, like count it, right? So we have to use count of star. Star will count all the students list. But they have told only male students, where they have given the gender that should be seen, and according to that you should retrieve, like s dot gender is equal to male. Actually in this question they had forgotten to give the this part, gender part, so I have added it in the question only. So here you can see gender. So to find the gender we need student. Okay, but also we have to check like compute total male students, that is the only rules. If they had given like specific section and all, then we had to take with section. Last one is very simple, list test marks of all students. So you want to list test marks, so while like listing the test marks we will mention the subject code and USN, that's it. Then we have 6 clauses in SQL, like select from where, group by, having, order by. Write it in this order only, because even SQL query gets executed in this order only. So select, we will select the columns from any one table, then inside where we mention condition. Group by will always be for column. Having will select any one particular group. Order by for ascending or descending order. Last concept of this module is explain BCNF. Remember, it is like 4 NF. So it must be in 3 NF. If I have to explain the BCNF in very simple way, remember, if there are two functional dependencies X and Y, X must be super key. Like now here you can see like SID is there. I want to make, like if I want to retrieve the instructor names separately, see here instructor A is instructing for like 1 SID also, and A is instructing for 3 also. So I may not understand it, right? Like two instructors are instructing for same SIDs. So what I'll do, I'll make next column as unique. How? Super key. After primary key, super key is used to uniquely identify the next thing, right? So if you make super key, that is only BCNF. That becomes the boss. So that's it for this module. I have covered 12 important questions. Don't forget to like, share and subscribe. We'll meet in the next video.